29 shows a circuit like this. You have 2 amps essentially flowing into a junction right there, and when the current hits this junction, it'll split across this way a 10, a 15, and an R. So there'll definitely be a split of currents right there. And the problem wants to know is what would this R have to be for that current going through the resistors here to maintain a potential difference of 8 volts across this section of the circuit right there. What would R have to be? When you look at the circuit, you'll notice that the 10 to 15 and the unknown resistance R there are in parallel. So one thing you can do here, you can write an equivalent resistance here, which is 1 over 10 plus 1 over 15 plus 1 over R. Now, the reason why I'm doing this is very awkward, so you're having the unknown buried in the very bottom of a fraction like that, but it is what it is. It's mathematics. It can be solved for without too much difficulty there. What that says then is that the 2 amps you have coming down through here goes through this resistor here, and the resistance has a single value of Req, like that. So this whole resistor network, including the unknown in there, is now reduced down to an Req. So what do you have now? You have the 2 amps traveling through one resistor, one equivalent resistor, with a resistance of Req, which is found using this awful equation right here, and the 8 volt potential difference across this resistor still persists. So now, since you have it reduced down to one resistor, you can just use an application of Ohm's law, I think, to find out your answer here. In particular here, the relation that the 8 volts is going to be equal to I 2 times Req. This is your V equals to I times R. This is just a straight up application of Ohm's law right there. So you can come down here and just keep plugging your stuff in here, and you'll get that the 8 volts. 8 volts is equal to 2 over 1 over 10 plus 1 over 15 plus 1 over R. So you have it all put together, physical in terms of Ohm's law. The unknown resistance still sits down in there, and I believe you can solve for that now using algebra. I got something like 12 ohms for that, so I think that's probably going to be the answer there if you numerically solve for it. But again, I hope you can get a little bit of the physics out of what happened here in terms of how we broke this system down. 2 amps having to go through 3 resistors in parallel like that. How does it split? What does it do? We don't really know exactly how it splits, but we know a potential difference of 8 volts is maintained across these 3 resistors here. We broke it down into parallel here, found a place to put our unknown right there, then just did a straight up application of Ohm's law across the one equivalent resistor, and was able to get the answer to fall out.